and thank you everybody for joining us today. As just mentioned, the Definiens technology really gives a detailed tissue marker readout from digital slide images, and this then allows a correlation with other important information such as clinical outcome data and genomic information that can then be correlated in this approach that is known as tissue phenomics. So during this talk, I'll give you an overview of phenomics from biomarker discovery all the way through commercialization. I'm going to cover the basics of tissue phenomics, and this includes a discussion about our underlying cognition network technology. I'll cover 3 diagnostic use cases and discuss the considerations and strategies for diagnostic commercialization using these technologies. So the underlying the tissue phenomics strategy is our Cognition Network Technology, or CNT. This technology was invented by the Definiens founder and our Chief Technology Officer, Dr. Gerd Binnig. Dr. Binnig is a PhD astrophysicist and a Nobel Laureate in the studies of nanotechnology. He invented the CNT with the goal of extracting more data from images. And whereas initially he focused on satellite images and more of the macroscopic world, it didn't take long before this technology found its way into the microscopic world, and now focusing very closely on applications in the analysis of digital pathology slide images. On this slide, I'm going to show just a very simple example of how this cognition network technology works. So for a human looking at a slide such as this is an H&E from a breast cancer cohort. When a human looks at this, we can easily see a number of different structures. For example, the nuclei that are present here. Now, when we look at the nuclei, we can see that, in fact, there are a lot of differences between them. Some of them are round, some are elongated. The color does vary, and these come from a variety of different sources. They include epithelial cells, lymphocytes, granulocytes, stroma cells, and tumor cells. But we also note when we look at these nuclei that they have some features that are similar across them. For example, they all have a purplish blue color and a similar texture that's present there. If we look to try to differentiate 2 of these different nuclei, though, such as shown in the circles here, we clearly can't do that just based on the characteristics of the nuclei themselves. These are both elongated, very similar in appearance, and I would think that we could probably use Photoshop and switch the 2 of them, and even the world's best expert wouldn't know that. However, we can look at these and determine that the one on the top is a stroma cell, and the other one is an epithelial cell. And the reason we can do this is because we're not looking at these objects in isolation, but rather cognition depends on the context of where, in this example, the nuclei exist. And this is the same way the human brain works is the way that the cognition network technology works. The first stay aspects of image analysis are 2 processes. One is to segment, and the second is to classify. So it starts down at the pixel level, where the technology looks at pixels and similarities between them in order to group these like pixels into larger superpixels, or what we refer to as objects. So in this case here, the pixels encompassing the nuclei have similar characteristics, and so they get segmented. The second step is to classify these. The classification can either be based on some a completely unsupervised machine learning, or it can be based on some known characteristics. So, for example, the color, the shape, or the density. And so using those 2 basic technologies, we can segment and classify all of these objects into nuclei. However, the next step is a little bit trickier in order to differentiate, further classify them into the stroma and the epithelial cells. And to do that, again, we have to use context. So if we look at the epithelial cells, we can tell that they're more crowded. So each individual epithelial nucleus has much closer nuclear neighbors than the stromal cell. So that's one way that the object we're trying to classify can be further differentiated. We also have a hierarchy of objects here, though. So not just nuclei, but if we step up a level, we can also segment and classify a lumen, and we know that surrounding the lumen is the epithelium, and surrounding the epithelium is the stroma. So this object that we're trying to classify, this nucleus, looks at its neighbor objects, but it also looks at its superstructures and knows its association with the lumen and with the structure that surrounds it.